Hello everybody, so today, last time we did our Sprite class, which I have right here. I've commented to everything, so if you want this, just let me know and I can send it to you. So I made, I haven't commented this, but I made a new thing that, a new constructor that takes all this stuff in, and that's about it. Everything else is pretty much the same. Nothing else has changed. In my game, I've also added a bit more functionality. I've created a boolean, which is a true-false true-false variable. Set it to false, and it's called rotation. And what this does is it basically determines whether or not, if you press the space bar. So what happens is, if your space bar is pressed, it's going to come in here. If rotation is true, set it to false. Else, set it to true. Meaning that if it's already false, set it to true. And that's what this is. This is kind of like an if-else statement. This little thing here, it's very powerful. You're going to see it quite a bit. I use it as here as well to determine scaling when I press up and down on the keys. So it's a very powerful one-liner if statement, and it's a question mark followed by the colon. So this is your first statement if it's true, and this is your second statement if it's false. Unfortunately, you have to use it a specific way in C#. You have to do the condition and then assign one. You can't assign in here. It's kind of really weird. So if it's true, rotate one way, else rotate the other way. So we'll see how that goes. It's very quick and very easy to understand here. There's Mario before. Just goes back and forth. If I press space, there we go. It's really finicky because it doesn't it switches it so fast before you can even press the button. If I press up, he gets larger. If I press down, he gets smaller. Ooh, there he is. So that's just fun with the scaling that I didn't get in the last episode. So nothing fascinating there. You're probably going to be seeing me use these quite a bit because these can actually be used in one-line statements when passing maybe different variable check-ins into functions and stuff like that. So other than that, everything else is pretty much the same. Sorry if my voice is a little crackly, but I do have a bit of a cold, or a sore throat rather. So today we're going to be doing inheritance, and what inheritance is it allows you to extend new classes off of old classes. So your new classes will now have all the previous functionality of a class that it inherits from, as well as all the new stuff that it creates it from. So first we're going to create our base class. We're going to add new item class. We're going to call this base game entity. There we go. Entity. Sorry, it's very tiny. I can't see it. Entity. Perfect. Okay. This is going to be part of our entities namespace. And this, sorry. This is going to be our base class, and a base class is the first class, or a base class is what a class inherits from. The other thing we're going to talk about is different kind of classes. We have the standard class, which much like the Sprite one here, can be instantiated. It has all the functionality of each of the properties and methods are all filled in with these brackets, giving code and stuff like that. So that's a standard class, but our second class, which our base game entity we're going to want, is we're going to want it to be abstract. How do we make it abstract? Well, we go public abstract class base game entity. So what does abstract mean? Basically means there might be functionality that's not necessarily implemented, and that you'll have to implement it in anything that derives from this class. Derive means a class that inherits from it. So this also has a second use for abstract class. Any abstract class cannot be instantiated, meaning you cannot create an abstract class. So if I went up here and went using entities, if I tried to say base game entity ENT equals new base game entity, the compiler is going to complain, and this is the error you're going to get. What did that do? So, there we go. Can I instantiate an abstract class or interface? So it's going to complain about that. So we'll just delete that for now. So yeah, basically it's just saying you cannot create an abstract class. And you don't want to, because we don't want there ever to exist a single abstract base game entity. Because base game entity is going to contain the most basic forms of information, and that's going to be a private string name, which is going to be the name of the entity, as well as private integer. I'm going to make it a uint, which is basically just an unsigned int. So instead of going from -4 million something to +4 million something, it's actually going to go from 0 to, no, it's 2 million, -2 million to +2 million, give or take a couple of thousand. It's going to go from 0 to 4 million, and we're going to have it as ID, not if, ID. So those are the two basic informations we're going to have. So this way, any game entity, anything in our game is going to have a name associated with it. It could be a character name, enemy name, anything, as well as a unique ID. So let's create our properties here for this stuff. And we are going to be, it's going to be a public string name with a capital N. And we're going to get said name. We're going to return name. Remember, make sure you use the lowercase version. Otherwise, you'll create multiple incursions, which causes it to go, what the hell am I doing? Name. Let me zoom in here, because even I'm having a... Whoa, a little too much. There we go. Even I'm having a little too much trouble seeing. So there's our first property for name set up. That'll allow access to the name, and public uint, and it's going to be ID. Now ID, we don't want ID ever to be set. We want to do that ourselves. So we're just going to have a read-only, and by making just a getter or a get, we're going to make ID read-only. So this means they can only get the ID. They will never be able to actually change the ID. Now when I say basically a unique identifier, I'm going to actually assign it every time base game entity is called. I'm going to assign it a new value that's specified by me. How do I do that? Well, first I'm going to create a private static uint, and we'll put in capitals. What do I call this? ID values. ID value, whatever. We're going to equal it to 0. Can't think of a better name right now. Now basically what this means, static means it belongs to the class and not the instance. So this here is an instance of Mario. It's an instance of Sprite, sorry, not Mario. Mario is an instance of Sprite, the class Sprite. This belongs to the instance of base game entity. This actually belongs to base game entity. So you don't actually have to have an instance to use this value. It will use automatically, and it will exist as long as the program is running. So what will we do here? Is this running? Yeah, okay. Still running. Sorry, it freaks me out and I don't think it's running. So what this will do is this will contain the value, ID will contain the value 0 starting at 0 as soon as the program begins its execution. And what we're going to do is we're going to actually assign this dot, well, actually I don't even need this, ID equals ID value. And then we're going to increment it after we assign it. You can do it that way, or probably the more understandable way to do it would be to increment it after, like that. I just like doing stuff on one line. That's just my personal preference. And then we'll new name equals nothing. So there's our first constructor. So when we call this, when we create any game, when we create the base game entity, it's going to come in here, it's going to populate name, then it's going to give a unique value, and it's going to increment this value. So it's going to start as 1, 2, 3, 4, 5, 6. It's going to go all the way up. And this makes sure that you never have any ID that ever matches the same thing. This is why you don't want to set, because if you had a set, somebody can set an ID to 0 or 500 times, and you don't want that. So we're just going to get the ID. Next, we're going to create our second function. So let me just put in the regions fields. I'll put some space there. Oops. So you remember that regions allow you to put stuff together and allow you to condense specific spots. I won't be doing this all the time. In fact, I probably won't do it. Probably won't do it for the next one. Actually, I probably will stop at just this one because if you don't really need it, I'll put them in later. And it's just a way to like help you organize your code a little better. It's nothing really necessary. So let's create our second constructor, base game entity, and this one's going to take in a string name. And what we're going to do is we're going to want to call the ID, so we're going to call in this. We're going to call in this base default constructor, which is this one right here. It's going to come in here, populate the name with nothing, and give it a unique ID. Then what we're going to want to do is we're going to do this. This instance. We're going to want to send this instance name to name. Boom. Constructor done. That's all the constructors we need because we don't want to create one that sets an ID. And that's about it for now. But there's a few things we want to do. We want to do some overriding. And what overriding does is it allows us to take functionality from classes that we derive from. Now, even though it's not stated here, this thing actually derives from object. Every class you ever do default derives from the base class object. Even Sprite, even though I don't say it here, it still derives from object. So we're going to go back into here so it can technically derive object. Like that. It's all good. There's Mario still spinning. So we're still going. But I'm not going to do that. Just for, we'll call this the base class. And now object has a few functions in it that we do inherit from because of it, but we don't want it to work that way. So we're going to override those methods inside object to make it work the way we want to. So the first one is going to be, how we do it is public override. When you hit the space, it'll give you some options of what to override. These three functions are in object, and everything in the class object and everything in C#, everything that extends from object has these three things. Equals compares two things. Compares the class, sorry. Get a cache code serves as function for particle, I don't know what the hell that means, and toString, which returns the string information of the object. We want to override this one and toString, so we want to override equals. There we go, and it's just going to return for now the base dot equals. So basically what it's going to do is it's going to call the object's version of equals, passing in the object that was passed in here. But we'll fix that later. Public override, and we want to override toString. So we don't want it to actually return the string of the base class. That defeats the point to even overriding something. You might as well just use the base class one, because you actually have this class, even though we don't write it, actually does have access. Because if we go back to our game, remember Mario doesn't have access to... Remember Mario, we didn't inherit from objects, so if we just go Mario, we can actually access the equals method from object. But that will just use the default version of object, and we don't want to do that. Sorry, I gotta remember to zoom in on some of these. So what we want our toString to do is we want our toString to return the name, leave a little bit of white space, and the ID. So what this will do is it'll take the name, leave white space, and convert this integer into a string. And it will return the string of name and ID. That's basically all this class is going to do. That just gives you simple debug information. Next is our equals. Our equals returns true if the objects are the same, false otherwise. So what's the first thing we want to do? Well, we want to determine if object is of type class base game entity. There's a couple of ways to do that. You can cast it directly by doing this. Object, putting the class name inside brackets in front of a variable will cast it to that type. However, this is dangerous. You see there's our ID and name and stuff like that. This is dangerous because if the object passed in is not of a type base game entity, it will crash. We don't want that. The other way is object is... I forget what the other one is. I'll go over it later. It's a bit confusing, but the one I prefer to use is known as. So how as works is as will. So let's create a base game entity temporary variable called ent, and we're going to say obj as base game entity. What this will do is if obj is a base game type of base game entity at somewhere down its hierarchy through the family tree, it will give entity a value. Otherwise, if it is not anywhere down the inheritance tree, it will be null. So if ent not equal to null, we know it is, first of all, an actual base game entity. So we can now use this to actually access the information of this object, because we've now cast it telling. So this object has passed the reference into entity. It is a bit confusing now, and I'll go over more in the hierarchy tree of inheritance later. It gets really confusing. But for now, we're still just working in technically our base, and I use in quotes, the base game entity, the base class. So what's going to happen is we're going to check if actually technically we can just do this. There's two ways to do it. I'm just going to do it the more common way. If entity dot name equals, so this double equals, single equals means assign. If you do this, we're going to compare it to this instance dot name. If you do this, you're simply just going to try to assign that name, and that doesn't make any sense. You don't want to do that. Double equals compares if the names are equal, or if you have this double and ampersand, this means and, meaning this condition or entity dot ID is equal to this dot ID. If we get those two values, return true, because the object is the same object, right? However, this is not a good idea, because this means both this and this statement have to be true, but we don't necessarily want that. What happens if we want to compare? What happens if we want to pass in an entity? It's really up to design. So I should leave it as and. If you choose to do it, you could also choose to do it as an or, which is double pipe. You can choose to do it that way. So this way, as long as either the name or the ID work, it will be the same object. But for now, I'm going to try going with double and. If those two are equal, then return true. That's one way to do it, but you could also actually just do this and put in parentheses, we'll put this. The difference between or and is that if this condition, if the thing is null, it's not going to attempt to determine if this is true in any way. It's just going to kick it right out. If you did an or here, this means it's going to check for this, and if this is null, if ent is null, you're going to try to access ent's name and it's going to crash, and we don't want that. We want and, so as soon as it hits the and, it's going to check. If it's null, then screw it. Skip this statement. Otherwise, if this is true, meaning there is something there, check its name and its ID compared to this instance's ID. And if they are equal, return true. Otherwise, return false. It's probably best just to go with the first way I showed you because it makes it more readable. The other thing is we don't necessarily actually need these brackets. You can actually take these brackets out. Boom. Ça va? The other way to do it is if you don't like temporary variables, is you could actually check game as this and put it into here and check to see that it's not equal to null. If obj as a game entity is equal to null, not equal to null, then you can actually cast obj here, and you're good. Works either way. It doesn't really matter so much. It's a whole bunch of different ways of doing it. So what I mean is you could also do, we're going to take this out, we're going to copy this part, paste this in, and I can do this. Put brackets around it so it determines where the condition is being checked. And then you can just say, oops, base game entity obj, and we have to put the brackets here, otherwise the name won't. The name will do. What's going to happen if you don't put these brackets here is it will try to say, okay, obj's name is cast to a base game entity. We don't want to do that. But this is just another way to do it if you don't want to use a temporary variable in any way. But to be honest, you probably should. So that's just two different ways of doing it. There's multiple ways of doing everything, but I'm going to go with this one for now. And then our string is done. So these are two overridden functions. You don't have to do these, you can just stick with the default ones. The default ones don't work as well, like it will actually compare, I believe object will actually compare, if we jump to it, yeah, I don't think it doesn't show it. Yeah, no, it doesn't show it. But it just compares, I believe, the actual reference. So, like I said, first things first, this is an abstract class, so as you saw, we can never instantiate it. So how do we instantiate it? We're going to make a class that derives from that. So we're going to go add new item. We're going to call this new item game entity. Did I spell that right? I cannot tell from here. And yes, I did. We're going to make it public, and we're going to make it inherit from entities. Spelled that right? Yeah. So here we have our game object. Now, I could go and write in stuff like private name and stuff like that, but I already have a class that does that for me. So I'm going to inherit from it. So how do we inherit? We use the colon followed by the name of the class we want to inherit from. And the name class we want to inherit from is base game entity. Now because these two are in the same, this and this are both in the same namespace, I don't have to use a using statement. But if they're in two different namespaces, you would have to be a using statement that leads to this one. Now every object can only extend from one base class. So currently we have the base class, base game entity, and we have the derived class, which is game entity. So game entity currently already has all the functionality base game. So if we actually go down to this one here, and I'm going to create a game entity, we're going to call it entity equals new game entity. Alright, if I come into here and I go entity, hit dot, you'll see we already have name and ID. So we have access functionality from this one in this class already, and this class has nothing in it. Pretty cool, eh? So you can build off without having to actually put anything in it. But I'm going to delete that. We're going to put that back in, and we're going to delete this as well. Alright, so we already have that. Now, what do we want our game entity to contain? We want our game entity to contain just a sprite, but a sprite has to be, we have to tell it where the sprite is. And we're going to say using display, and we are going to tell it, we're going to create a sprite. We're going to call it sprite. I don't want to call it sprite. Too many names of the same name. Yeah, we'll call it sprite. Little sprite. There we go. Little sprite is private. Like I said, by default, if you don't put anything as private, but we'll put something. There we go. And we're going to need to have access to said sprite. So we're going to make a public sprite. We're going to do a get. We're going to return sprite, little sprite. We're also going to set little sprite equals value. So now we have the ability to set our sprite and all that. We have access to all our sprite information, such as the asset name and other stuff. So let us continue on with doing this. So what else are we going to do? We already have a name. We need a constructor. Now this is important. Public game entity. Create a default one here. And what our default one is going to do is it's going to call our base class default. So now what it's going to do is it's going to come in here, and now it's going to, I don't want that. There we go. Sorry, I keep forgetting to zoom in. Now what's going to happen is it's going to come into the base class, which is right here. It's going to come into this constructor and do this constructor, giving it its default name, which is nothing, and a value. And then it's going to come out and it's going to populate. What do we want to do? Well, we want to create our new sprite. So sprite equals new sprite. Just like that. But we also want to give another constructor that takes in a name, right? So base game entity string name. Now we already have a base class that needs a name, so we'll do that. So what we're going to do is we're going to call the base and we're going to pass in name. So that means now this base one's actually going to come into this class, this one right here, which is going to call its default constructor here, do the population, set the ID, and then it's going to set name to name, and then it's going to come back here. Now, this is where the problem is. You can't do this dot this. Yeah, see, don't work like that. So you have to make sure we still have to populate, we still have to create an instance of our sprite. So we still have to say equals new, our sprite equals a new sprite. There you go, eh? So there's two constructors. So that's all good. So there's our game entity class derived from a base game entity class. So it has the functionality to get the name and the ID of the base class, as well as it has access to a sprite. So let's go back to our main program. Well, first let's run it, see everything's working hunky-dory. There we go, everything's good. So let's go back to our class, and we're going to change this to a game entity. Now Mario is a game entity. So a few things have to change here. He's no longer a sprite. He's now a game entity. The game entity only has a constructor that takes in a name. So we can delete the position. So now our thing is called Mario game entity. He's called Mario, and he's going to have an ID of 0. Next, what we want to do is we want to set the texture of the sprite. So we're going to want to call sprite dot asset name. We're going to set asset name to equal Mario. You can make the asset name and the player name the same thing. It works either way, doesn't matter. And we're also going to set Mario dot sprite dot position. Position, which equals new vector 2 150 by 150. So that's all set up. So basically what you have to do in between is now set up everything so that the sprite is in between. Flip in between the scale, all that. We also have to now load the sprite, get the origin, get the texture using the sprite. So see how now we have a lot of dots going on, because now it's not just Mario's not just a sprite. He's actually a game entity that contains a sprite. So we have to call this thing here the property to get all the sprite information. And see how much confusing, oh my god, look at all this crap. So much crap going on. Holy crap, just a lot of Mario sprites and Mario everywhere. And sprite draw. So it's gotten a little more complicated already. So let's run it and no, I have an error somewhere. Oh, still have 2 more. There's right there. And there's our Mario. So a lot of work, but now our Mario has a name, and you can't really see it at this point because you would have to do it in the console to be able to tell if it's changed or not. You'd have to do console to be able to see the name or the ID. Didn't mean to do that. We'll just drag that back onto here. There we go. So yeah, there we go. So that's all inheritance is. It just allows you to, so we took this class which has a lot of information. Well, I say a lot of information, but it's just 2 pieces of information. You can ignore this because basically it's just saying, oh well, you overridden these 2 objects. Why aren't you overriding this one? Well, let's override that one just to shut it the hell up. We're going to say public override. Get hash go. That's just going to call return the base one. Like I said, this is stupid to use because it wastes time a bit because it's got to put stuff on the stack and all that crap. You don't have to really care. But we took this one that has, you know, the most work and detailed information, and it does all the work of this one here. So this one's doing all the work, or sorry, this one's doing all the work, and this one's taking basically all the glory. The other thing we learned today was overriding, which allows you to override functionality to basically let you implement functions from classes that you derive from to change the functionalities. So, like I said, toString is a function and object, which everything inherited from, even game entity. We are now overriding it and telling it this is how it's going to work. Because it wouldn't actually display that. It would display a bunch of stupid information. So that's about it for inheritance. It will become a little more clearer as it comes along, but basically the only thing you have to remember in inheritance is 1, abstract classes cannot be implemented, and 2, derived classes contain all the information of base class. There is another little thing that we want to do. So we have the 2 keywords public, private, which I've mentioned before. The only way in-game entity or anything that derives from game entity or anything like that is going to have any access to the base class is through the properties here. So game entity cannot directly get name. It has to actually call the property. But I don't want to waste my time doing that. I want to actually allow my game entity to have direct access to the name. And how we do this, we use the 3rd access modifier, which is protected. Protected will now allow game entity to call name directly. So if we do this dot name directly, as opposed to having to call this one. So you notice ID is not anywhere displayed here because it doesn't have the access to get at it. It's still private because we don't want anybody to mess with these IDs, even anybody who inherits from us. So public means anybody can access this stuff. Private means only those in the class, and protected means only those that derive from said class can use it. So that's about all the information we have for today. If you have any questions, let me know. Thank you for watching, and yet again we'll leave with Mario twisting in the wind and woo. Whatever. Woo. Blowing like the wind. Anyways, thank you for watching. Bye now.